Welcome back. This is an ALEKS homework video on using the general properties of Gibbs free energy. Okay, finally an easy ALEKS problem. It doesn't look easy, it looks scary, but it's not scary. It's actually okay. I think you'll be fine at this. It's going to give you a standard reaction energy for a specific equation. All right, so here's my equation. I've got all gases here, nitrogen gas and oxygen gas. Okay, making 2 moles of nitrogen monoxide, all in gases. They give me the standard reaction free energy, the available energy for this, as a positive 173 kilojoules. All right, so as long as it's in this order, N2 plus O2 yields 2NO, or some kind of modification of that, whether it's being multiplied or divided, where every single thing is, every set of moles are divided, the 1 can be divided by 2 or 10 or whatever, or multiplied, you're going to take the 173 and either multiply it if everything's being multiplied or divide it if everything's being divided. If it's going backwards, if you notice that your reactants are actually named first, like in this second example, I've got 4NO yields to 2N2. Well, what's happening here? It's just going backwards. I've got it going backwards here and then something being done to it, either multiplied it or divided. So if it's going backwards, I simply need to take the negative. So if they give me a Gibbs energy of 173 kilojoules and I've got a backwards reaction, then I take a negative 173 kilojoules. All right, so that's basically it. Let's look at these three and see if this helps you with your problem. So the first one I see is in the same order that I've got it. All right, it's got N2 plus O2 going to NO. But instead of 1 N2, it's got 1/4 N2, and then 1/4 O2, and then 1/2 N2. When I look at that, all that's being done is every single one of these moles have been divided by 4. 1 divided by 4, 1 divided by 4, 2 divided by 4, which gives you 1/2. And so I'm going to, since it's in the same order, I'm going to leave it 173. Okay, my calculator, 173, and I'm simply going to divide that by 4. Okay, so if I divide that by 4, then I get 43.25. Okay, I'll write it down here, 43.25. So they're asking me to round it to the nearest kilojoule. Well, so in this first one, it's going to be 43 point, I always put a point because I just don't trust ALEKS, 43 point kilojoules. All right, and that's it. So look at the next one. The next one doesn't start with N2, it starts with NO, which means that's my reactants. And then it gives me an arrow, and then it gives me the two, or it gives me the products, and then it gives me the reactants. That means this is going backwards. So instead of starting with 173 as my starting point, I'm going to start as negative 173 because this one is going backwards. And a backwards, it has to be negative. If the delta G, standard delta G is 173 in one direction, it's going to be negative 173 in the other. So 173 negative, and now what's being done to it, right? Well, I had 2 NO to start with, and now I have 4 NO. I had 1 N2 to start with, and now I have 2. So everything is being doubled. So I'm going to take the negative 173, and I'm going to double it, okay? And I get negative 346, and that's what I'm going to give you. So this is going to be negative 346, and then I'm going to put the dot, right? So kilojoules. And the last one is also negatives. So I start with negative 173 negative, and then I realized that nothing's been multiplied or divided. It simply just wrote it backwards. So if I wrote it backwards, this is going to simply be the negative 173, and that's what I'm going to write, negative 173 point kilojoules, right? I hope you find this easy. You need some easy problems.